Hello, it's Keith here, and this is lesson 2 of the simple series of my MIPS assembly programming tutorials. Simple series, we do a single task each time in a simple example, self-contained example. Today we're going to be moving an object around the screen, a little bitmap sprite around the screen with the joystick. So we've got our character sprite here, our mascot here, and if I figure out which controls we're actually using today, it will just vary depending on the system. Here we go. So we're able to move our character around the screen with the digital pad here. Now the sprite is being drawn just as a bitmap straight to VRAM, and we've got limits to make sure the object can't go over the screen. Now this is no real amazing example by any means. It's just a simple thing to get you started if you're looking to do some graphical programming on the N64 and you want to be able to read in input and process it and show some response to the screen. So this maybe will be useful to you as a simple starter. It's something you can build on for your own projects. Okay, well let's go over to the source code and let's take a look. Now this builds on the previous bitmap example I did, so I'm going to go pretty quickly over the parts that are not really changed since last time. So at the start we've got the header of our cartridge here, the start address, things like that, and we're also importing the binary bootstrap for the system. We always need a bootstrap. And then we've got this these start initializations, which is setting up the screen. We've set up a 320 by 240 screen, 16-bit per pixel. Now we are importing, if I find it, we are importing the bitmap for our mascot. This was used in the previous example as well. The file was created with my Sprite editor. It's free and open source. You can get it from my website. It's also included in the downloads for the MIPS tutorials. So that is the Chibico mascot, the mascot that you saw moving around the screen before, that we're showing to the screen. Now we're using similar bitmapping code to before. I've made a slight correction to the screen base here. The first few lines are actually off screen, and weirdly enough, there's a 1 pixel correction here so that we could get the very top left. I guess that's to do with the way the sync position of the drawn data to the visible screen, and maybe you would need to correct that on a real monitor, a real CRT. But anyway, this is correct for the emulator we're using today. So this is calculating our VRAM destination. And we've got a draw bitmap function here, which is basically the same as before with one subtle difference. Now, before we were drawing the bitmap to the screen, this time we're XORing the bitmap with the screen. So we're basically performing an invert operation with our bitmap data and whatever is already on the screen. Now, the reason we're doing this is if we've drawn our character to the screen and we now want to move it, we would need to take it away first. And so because we're using XOR, we can draw it a second time and it will disappear. So XOR, very simple way of doing things, allowing us to remove an object quickly from the screen. So we're loading the source bitmap data, we're loading the current content of the screen, we're XORing the two together, and we're writing the new content back to the screen there. So that is the XOR operation to our draw bitmap. So our draw bitmap will do the job of getting the bitmap to the screen, but it's our draw player routine that is actually showing the player at the XY position that we specify. So how does this work? Where we're loading the X and Y position in words from our memory here, calculating the VRAM destination, specifying the fixed width and height in pixels of our object, drawing it to the screen, and then we're returning. So draw player will do the job of drawing our mascot to the screen. Okay. So that's how we're getting our bitmap to the screen. So that really the remaining issue is how do we actually get our data from the joystick. Now the joystick we read in from something known as the PIF. The PIF is it's either peripheral interface or the parallel interface, but it's basically the hardware that our controllers are connected to. That's what it is, what it does. Now first of all, we need to do some initialization. We need to get it set up correctly by writing a status value to this address here. That is the base. We are offsetting that by 3C and writing the value 8. I'm told if we don't do that, the PIF will lock up a few seconds after the machine starts. So we have to do that first, but then we have to send an initialization sequence. We do that via the serial interface. So basically we have an initialization sequence that will configure all of our joysticks, and so we need to send these values here for the first 4 joysticks, an end command, and then a new value for the status register there. So we're going to send that data. So that's the address we want to send, PIF init, but we actually need to convert that into the hardware address, not the actual running address, and so we mask that with this value here. So we calculate the address we want to send with the mask, and we write to register 0 within the serial interface. Now the serial interface has the registers from that address there, A48000000, So we're writing, in this case, the source address, and then we're writing the destination address, which is the start of the PIF RAM here. So that is our destination address, and by writing that to register 10 within the serial interface, the transfer occurs from our source to our destination, and that has initialized the joystick. So that's got our joystick set up. Now what we're going to do then is we're going to start our main loop here. So first of all, we're going to set the initial position of our character's object to 0, x and y 0, and we're going to draw the starting position. What we're then going to do is we've got our main loop here, and we've got a very crude delay, just a simple loop here to slow down the N64 enough that this is actually usable. We'd probably want to do a VBlank or something really, but for today's purposes that will do. Now after that, what we're going to do is we're going to read in all of the data from all of the joysticks. So we need to read in from the PIF to some RAM. So we've defined some RAM within our cartridge. Now this will end up in RAM. So these bytes here, these words here, are the destination for the status of all of the joysticks here. So what we're going to do is we're going to specify that as the destination, writing again to register 0, which is the RAM register here within the SI. So again, the SI, same address as before, and again we are converting it to a hardware address. And then we are specifying the source this time, and the source is again the PIF RAM start. It's the same address as we wrote as the destination before, but last time we wrote to register 10, this 10, this time we're going to register 4. So that is the read register, and by writing to that register we read in from the specified address that we wrote to the RAM address that we specified before, which is the RAM that we've allocated for our joystick. Okay, so this is basically a DMA, and this will immediately read in the data from the joystick. Now what we now need to do is we need to specify the correct RAM offset for the actual joystick we want to read in. Now if I just run a previous example, this is an example from the platform specific series. Now this is the raw data that we are reading in here, and so what we're going to do is we want to read in these directions here. That is joystick 1's digital joystick there, so we want to read in the joypad, I suppose. We want to read that in, and so what we're doing here is we're loading the address of the RAM that we've loaded in with the joystick state here, and we're looking at offset 4, which is the digital joystick of player 1, the digital joypad. If that is a 0, if all of the bytes in there are bits in there are 0, then nothing's pressed, and so there's no directions to process, so we're simply going to wait until there are for today's example. Now once a direction is indeed pressed, we need to do a few things. The first thing we need to do is we need to remove the sprite from its current position before we move it. So we do that simply by running the draw player routine again. Because it's XOR, that will take the sprite back off the screen. So the sprite is gone. Now what we're going to do is we're going to load in the X and Y position of our player into A0 and A1, and then we're going to test each bit in the byte that we've read in from our joypad, and we're going to see what each of those direction bits is. And if the player is trying to move left, we're going to then consider the player's position, and we're going to move left provided the player isn't already at the limit of the screen, in which case they can't move left, otherwise they go off the screen. So we're going to do that for each direction. The first direction here is bit 0 here is the right direction, so we're testing that bit within the value we read in from our joystick here. Our joystick is being stored in A3 here, so that's our digital joystick there. Joypad, I keep calling it joystick, so I am mixed up so many systems of program. So we're testing the right bit of our joypad with this test here. If it's not pressed, we're simply going to skip to not right. But if it is pressed, we're then going to basically compare our current position to the far right of the screen minus the width of the sprite here. Now if it's not already at the far right of the screen, then we're going to actually process and move right. But if it is at that far right position, we're going to act as if the button wasn't pressed and skip it. So that's doing the right. We're now going to do the same for the left. That is bit 1 within our read in byte, and if that is a 0, then that button isn't being pressed, so we would skip. But if it is being pressed, we're now comparing to the position 0, our X position. If our X position is 0, we're at the far left and we can't move. If we're not at position 0, we can move, so we're subtracting 1 from the X position. We now do the same for down and up with the Y position. So you can see we're testing the down bit here and the up bit here, and we are moving down the screen by adding 1 or up the screen by adding -1. Of course, to A1 this time rather than A0. Now after all of that, we've updated our X and Y position, possibly, and we're storing the new ones, whether we've changed them or not, back into the X and Y. We're drawing the updated player position to the screen. Now, of course, this means that if we're actually already at the far left, we would have removed the object from the screen and redrawn it very quickly. So if I'm pressing, where is it? You can see maybe that the sprite is flickering there, and that's because we were removing it and redrawing it briefly. And so, as I say, that's because we're assuming we're going to make some movement. Sometimes we won't. Now, of course, it's pretty obvious to state that I'm drawing this straight to the VRAM buffer. That isn't a very efficient way of doing things on such an advanced system as the N64 with its 3D graphics. But this is just a very basic example. There's two reasons for this. Firstly, I'm an 8-bit, 16-bit programmer, primarily 8-bit. So this is a 64-bit system. It's way outside of what I ever imagined covering. So it's not something I'm particularly interested in. And I simply don't have time to learn how to do 3D rendering on the N64 when really I want to be doing 2D rendering or maybe 3D rendering on an 8-bit system. So this is really all I'm covering in these tutorials. It's the idea is to just get you started, allow you to have a play around with the N64 and the MIPS. If you want to go ahead and do 3D programming, go ahead and do 3D programming, but I'm afraid it won't be covered on this website. Anyway, if you've liked what you've seen, please like and subscribe, because we'll be coming back to the N64 later, I'm sure, and we'll be also looking at the PlayStation as well and doing similar things on the PlayStation. So there's going to be some more MIPS coming. I hope you've enjoyed what you've seen today. Thanks for watching, and goodbye.